Greetings, YouTube. Beautiful mind here. This question comes in from our applied statistics course. It comes from section 5.4, question number 18. It says the population average and standard deviation are given below. Find the indicated probability and determine whether a sample mean in the given range below would be considered unusual. If convenient, use technology to find the probability. So I think a student had a question: how to find the z-score. I think she was saying how to find the probability because she was getting really, really high z-scores. So I'm just going to kind of work this one and see what happens when I do it. So let me see. For a sample n equals 36, find the probability sample average being greater than this and less than this. Okay. So we're asked to find the probability the x bar is greater than 12,558, but less than 12,000. Wait, what? Being greater than 558 and less than. Am I missing something? Being greater than. How is a larger number to the left? Otherwise, other than that, it should have like a probability of 0. Find the probability of sample mean being greater than 558 and less than if. Let me see if that's a typo or not. I feel like that's a typo. Let me go here. Oh, do they want these to just be separate questions? Greater than 558 is that. That's fine. Okay. Right. Okay. Okay. Yeah. Okay. So what they have is what's going on. So I'm trying to condense it into one. Let's look at it as two separate, right? So we're gonna look at it as two separate, right? So then for a sample of and find the probability the sample average is greater than. So the probability I think is the x bar is greater than the 12,558. So I'm just gonna say and the probability that x bar is less than 12,555, right? It says that mu is 12,555 and population standard deviation is 2.1. Okay. So because n is 36, that means notice that n is larger than 30, so that means we can use a normal. It can be approximated using a normal distribution. Let me see. So if we want a z-score, that's going to be what? X bar minus mu divided by sigma. That's mu, okay. So then for the first one, let's do 12,558 minus 12,555 over 2.1. I'm going to use my calculator here. Okay. Reload and refresh. Okay. Let's see. 12 here. Let's do like this. Clear parentheses 12,558 minus 12,555 divided by 2.1. Let's see if I'm doing this right. I'm going to look back. Okay. Divided by the square root of n, right? Because we're doing simple mean, yeah. Okay. Square root of n. So right here, I forgot my divided by the square root of n. So here, we're going to say divided by, I think it was what, 36? Square root of 36. Okay. So then in my calculator, I'm just going to recall and I'm going to insert 2.1 divided by what, 6? Close parentheses. Okay, 8.57. That looks good. So let's see. Notice this z-score is 8.57. I'm not sure if the student is aware of the question help or not, but this little menu that I'm pulling up here, you all actually have access to this, all right? I don't know how to get that to go back to the way it was. Let me see if I go back to this. Okay. So right here, it says, so the probability the sample mean is greater than 12,558 is equal to the probability that the z-score is greater than 8.75. This probability corresponds to the right of 8.57. Okay, under the standard normal distribution. To find the area to the right of this, first use technology, right? So I know the student's question was how to find the probability when the z-score is so high. So this is a case where you would use technology. You see, like when I do my calculations, I use the TI-83. What is this? I forget how to do it. Let me see if I can get it going. Z-score, probability, distributions. So on this TI-84, I think over here to the right it says variables. Above that it says distribution. I'm going to hit second variables to open up distribution. I'm trying to think of what's the right one. We want probability distribution. I think it's number 1. I'm going to go with number 1. Dang, I don't know how to use that one though. Let me see. I need the parts that it needs. I got to see an example. I'd have to look up how to use that because I don't know offhand. I don't use that on a normal. But it can be done in a TI-84 or something of that nature. So with it being so high, I think you could do it in Excel as well. Okay. So it says the area that corresponds to 8.57 in the standard normal is 1, right? So it's really, really far to the right. That's a really, really high z-score. So the area to the right of it is essentially 0. Like, because of being so far to the right, the area under the curve is essentially 1, and then 1 minus 1 ends up being 0. So then the probability that x is larger than 558 is essentially 0. Then we go back to find the other one. Yeah, because I think our chart doesn't go that high. Let me see if it's on this chart. Let me look at this chart for this course. I'm pretty sure it doesn't go that high, but yeah, we would have to use technology. This one, right? And then tables. Okay, we'll go ahead and I'll show you how to do it in a calculator. Let's see. I think it's this one. Tables. Not the t-score, standard normal, right? So then, yeah, all right. Okay, so let's see it in technology. So what I'm going to do, this is 5.4. Let's start there. This one. And I know that we did it in the text. I'm just going to kind of scan really quickly and find an example. Not that one. There it is. This one, right? This is the one on 84. So you need the 10,000. That's just I think I forget what the 10,000 is. It's something like either you're accumulating a lot of points or how far left you want to start. Let me see the 10,750. So in this example, is less than this, right? So the 10,750 is your X bar. 1043 is your mu. 550 was the sigma divided by root n. Okay, so if we apply that to hours, so let's go back here and let's actually open this up. Okay, so if we want to use this, we need to go like negative 10, 1, 2, 3. Okay, then the X bar for us was 12,558, and the answer should be 1. Our mu was 12, nope, that's not a 12, 12,555. And then our denominator, I'm going to put in a formula, was basically the 2.1 divided by 6. Okay. And we should get 1. Oh, go to. All right. I think it's at 2.1 divided by 6 is the trouble. So let me just do 2.1 divided by 6. It's 0.35, okay? So then let's just change this to 0.35. It should work now. Let's see, what else? Oh, parentheses, there's extra parentheses in here. Okay, doggone it. I just can't get this to work. 10,000, 1258. Let me see if I put maybe 10,000 might not be enough. Let me try 20,000, see if that makes a difference. Let me see. Let me try. Let me try this. So I will match theirs. See if I can reproduce theirs, and then I'll get it to ours. 84 plus normal 10,000. 1, 2, 50. Right. Oh, CDF. Oh, we did PDF. Okay. So let's go. Let's recall this, or actually, that's good. Let's go here, and I think what we have is fine. And then let's go back to distribution, and it needs to be the CDF. Okay. There it is. And it didn't matter if we had the 10,000. I just chose the wrong function. I'm totally like blanked out. Okay, so, but yeah, so there we go. I was like, okay, so yeah, for when you get such a large z-score like this is where like a graphing utility or something of that nature would come into play. So the probability, so the area under the curve to the left of this z-score is 1. So then the probability that z is greater than 8.57 is going to be 1 minus 1, which is 0, right? Okay. Okay. So then let's do the same thing for the other one. I think we want it less than the 12,555. So I'm gonna just use this and see if it works. So the 10,000 can stay. The 558 needs to change to 555. That one should be 0. Yeah. Oh, 50. Okay. Well, there you go. Let me see something. Am I missing something? Oh, it's gonna produce a z-score. Then we find the probability. Yeah, that makes sense. Okay. Okay. So that's 50%, right? Okay. So then it says. So what we just calculated was the second part, that the probability that the x bar is less than 12,555, right? Find the z-score. That probability ended up being 50%. Okay. So again, just with a large z-score like that, you have to use technology, and you just have to essentially just do the best that you can. I know that everybody doesn't have like a Texas Instrument. You're welcome to try this, but you'd have to download like a ROM and find it. I'm using this website called chemtech.net. I mean, for these purposes, it'll be fine. Um, so for the larger than the 558 is 0, and less than the 555 was 50%. Let me see. I think that's everything. And again, to determine if the sample mean with these characteristics is considered unusual, and recall that an event is considered unusual if it occurs with a probability of less than 5%. So this sample mean is not unusual because it's greater than 5%. Okay, it was an adventure to be doing it off the cuff like that. Okay, but yeah, we had to use technology to answer your question. Okay, on that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day.